Welcome to Derivatives 11, Differentiating Inverse Functions, where we will spend time talking about inverse functions and then find the derivative at a given value of x for the inverse function. Let's move along and see what it's all about. Definition of an inverse function. G is the inverse function for f if f of g of x is x and g of f of x is x. F of x equals y if and only if x equals the f inverse of y. And here is the definition of an inverse function, or sorry, the derivative of an inverse function right here. Let g of x be the inverse function for f of x, and let c be a number such that f prime of g of c does not equal 0, then g prime of c equals 1 over f prime of g of c. Wow. Really what you need to focus in on is remembering this right here. And the other thing I would like you to remember is that if f of 1 equals 3, then g of 3 equals 1. That's the way inverse functions work. They undo each other. This is very key concept right here with inverse functions. You need to remember this. So remember this, because otherwise you're not going to be able to do these problems. Example number 1. Let f of x be x cubed plus 2x. And let g of x be the inverse function for f of x. Find g prime of 3. Alright. So, we need to find g prime of 3 is going to equal 1 over f prime of g of 3. So in order to do this problem, I need to find f prime of x, and I also need to find g of 3. So I am going to put 3 equals x cubed plus 2x. I'm trying to find g of 3 right now. 0 equals x cubed plus 2x minus 3. Alright, so let's see if we can factor this thing. Okay, we'll use synthetic division. We'll try x minus 1. So we've got 1, 0, 2, and negative 3. Bring down the 1, multiply this 1 times this 1. That's 1 there. Bring that down, add those two together. 1 times 1 is 1. 2 plus 1 is 3. Multiply 1 times 3, 3. Hey, that becomes 0. Excellent. So we have the two factors of x cubed plus 2x minus 3 are x minus 1 and x squared plus x plus 3. Set both factors equal to 0. X squared plus x plus 3 equals 0. If I use the discriminant b squared minus 4ac, I get 1 minus 12. that will be a negative 11 in the radical. So there are no real roots. No real roots for that, so the only answer is 1. So that means that f of 1 equals 3. So g of 3 equals 1. Hey! Told you we needed to remember that one, and look at the example I gave on the previous page was exactly that. Alright, now I need to find f prime. Alright, so f prime of x equals 3x squared plus 2. Alright, so g prime of 3 equals 1 over f prime of g of 3. I don't know why that's doing that. I think my hand's getting caught on the slate. So g prime of 3 equals 1 over f prime of 1. G prime of 3 equals, what was f prime again? Oh, I have it right there. 3 times 1 squared plus 2. 1 over 5. And there's the derivative of the inverse function at 3. I think we'll need to try that one more time. Alright. Once again, find g prime of 3. So we're going to set this equal to 3 to find out what g of 3 is going to equal. 3 equals 2x cubed plus 3x squared plus 6x minus 8. 0 equals 2x cubed plus 3x squared plus 6x minus 11. So let's try 1 again. 2, 3, 6, negative 11. Bring down the 2. 1 times 2 is 2. Add those two together, 5. 1 times 5 is 11. And that would be, whoops, 1 times 5 is 5. I'm trying to get ahead of myself. 11. So let's see here. We've got 0 equals x minus 1 times 2x squared plus 5x plus 11. Okay, again, b squared minus 4ac, the discriminant, that would be 25 minus, wow, 88. No real roots for this quadratic, so x has to equal 1. That means that g of 3 equals 1, because f of 1 equals 3. So let's find out what f prime is. F prime of x equals 6x squared plus 6x plus 6. So g prime of 3 equals 1 over f prime of g of 3. We just determined that g of 3 equals 1. So g prime of 3 equals 1 over f prime of 1. So g prime of 3 equals 1 over, put a 1 in for here, 6 times 1 plus 6 times 1 plus 6. G prime of 3, 1 over 18. And now for the craziness, find the trig derivative of an inverse trig function. Sorry, find the derivative of an inverse trig function. This is really crazy. Alright, this one we are going to approach in a different way. We're going to think of it this way. What is the tangent of tan inverse of x? What does that equal? X, yes, because those inverse functions undo each other. Watch this craziness. Let tan inverse of x equal theta. Then you have tangent of theta equaling x. Alright, now what we're going to do is we're going to find a triangle here. Alright, and we're going to put theta right here, and the tangent of that angle is x, or x over 1. Opposite side x, adjacent side 1. Okay, what is the hypotenuse going to be? Use the Pythagorean theorem. That hypotenuse squared equals x squared plus 1 squared, so this hypotenuse is the square root of 1 plus x squared. Alright. I'm going to use g of x again, so g prime of x equals 1 over f prime of g of x. So g prime of x equals 1 over f prime of theta. Remember, because we let the inverse function be equal to theta, so I'm just making that g prime of x to be theta. So we have to find f prime. Okay, f prime is tangent theta. F equals tan x. F prime equals secant squared theta. So let's see here. What is the secant of this angle theta? That would be the reciprocal of cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. So that would be, let's see here, 1, square root of 1 plus x squared over 1, quantity squared. That's what f prime would equal. F prime equals 1 plus x squared. So the derivative g prime of the inverse function g prime of x is going to equal 1 over f prime of theta, 1 plus x squared. This will conclude derivatives 12 derivatives of inverse functions.